once again after being taken offline.
Super outbreak. So we'll take a look at the environment from the April 27th event and compare it to the April 3rd and 4th, 1974 event. And sneak peek, we're going to see quite a few similarities in the two environments, showing you just how perfect things need to be for prolific tornado outbreaks like this to occur. Just a quick note before we dive in here. This particular article here from the AMS bulletin is a really great resource of information on the April 27, 2011 outbreak. It goes in depth into what we're going to talk about in this video, which is the environment surrounding the meteorology surrounding the outbreak. But it goes through the chronology, some of the damage, and a lot of the impacts from this event. So if you're looking for a more in-depth publication that is going to go beyond what we're going to talk about in this video, this is a really great resource. I'm going to put the link to this article in the description below. So let's go ahead and get started here. And once again, this is just the Alabama portion of the event. You can see many of these tornadoes were very strong and long track tornadoes. You can see the very long tornado tracks there. And the story of this event is going to start all the way back a few days earlier. So we're going to start here. This is April 24th, 2011 here. So 3 days before the event. We're going to go all the way back there and kind of trace the synoptic pattern back here. So let's go ahead and look here. This is the 500 millibar pattern on April 24th. And you can see fairly zonal flow, but you can kind of see this trough start to transition in to the western half of the United States here. And as we go forward in time over the next couple of days, that trough really starts to dig in. But you can see it is an absolutely massive trough. You can see it extends basically throughout the entire United States. A general rule of thumb when we're looking at determining how quickly a wave pair, a ridge and a trough, is going to move is by the distance between that peak of the ridge and the base of the trough. And a general rule of thumb is when you have that distance between those two is significantly less than the size of the U.S., it's going to move pretty quickly off toward the east. But when it starts to that wavelength starts to increase, it's not going to move a whole lot. So we can see here, this is the axis of the trough, and the ridge is not even on the picture. The top of the ridge is not even on the picture. So this is a pretty massive long wave trough here. So this was not going to move anywhere. And April 27th, as you may know, was part of a multi-day severe weather outbreak, tornado outbreak specifically, that started out across the southern plains and just kind of moved its way slowly east toward kind of the Arklamis area, and eventually on April 27th and 28th into the southeast and eastern seaboard there. So this big old trough was not going to move anywhere very quickly at all. And that's why we were able to sustain rounds and rounds of convection here. You can just see as we go through toward the 26th and 27th that this trough is just absolutely sitting there. It is not moving at all. But we have these little short waves embedded in the flow that really helped kick off these rounds of severe weather. Numerous little short waves, little kinks in the flow that were sort of, as we say, little engines that were able to locally increase vorticity, advection, and lift out ahead of them to produce storms, severe storms, significant severe storms in those locations. And we'll talk more about that as it pertains to the 27th here in a second. So we are going to start on the evening of the 26th. So this is the evening of the 26th. This is a kind of broad scale radar view. You can see multiple tornadic supercells ongoing across parts of northeast Texas into Arkansas. And as we go throughout the night, these storms congealed into a massive QLCS with lots of little kinks in the line here, almost a line echo wave pattern type deal, where you have multiple sort of waves in that pattern, lots of kinks here in this QLCS that were tornadic and produced tornadoes. And this was initiated here. We'll go toward our 500 millibar map again. You can see once again that big long wave trough here, nice short wave here, and we'll go down to 700 millibars, and you can see it a little bit better here. So here's 700 millibars, and you can see a very, very well-defined shortwave. This is at, let me get the pen off there. This is going to be at 1Z, so you can see a very, very well-defined little shortwave embedded in the flow that really helped initiate thunderstorms there across northeast Texas into Arkansas. And as the night moved on, the forcing became a little bit more linear in nature. We had a very strong increase in the low-level jet. You can see here that is going to be 45, 55, 60 knots here of flow out of the south and southwest here across the region. That allowed storms to really organize into a line segment as forcing kind of was focused very strongly in this region. So we were able to get a very strong QLCS to develop because of that. And this initial QLCS was able to organize throughout the overnight and early morning hours as it moved through Mississippi and Alabama, producing several tornado reports. You can see right in here a little sort of embedded vortex there. And let's go ahead and zoom in here to the radar imagery. We'll go through time here, and you can see we go forward here. This QLCS is going to really make its way into Mississippi and Alabama. Very, very strong. You can see a very strong vortex there start to wrap up just to the south of the Huntsville area there, and this produced tornadic activity, and there was lots of tornadic activity on the line. And this was, I wouldn't say it was not forecast, but the intensity of the line, and we're going to talk about this secondary area of convection here that produced another QLCS. The intensity of both of these lines were kind of caught meteorologists a little bit off guard, I think. And there was lots of tornado damage and straight line wind damage across Mississippi and Alabama from these storms, and that would create problems later on that day across the region because power was knocked out, and that made it, with an impending very dangerous situation on the 27th upcoming, the afternoon of the 27th, that made it really difficult and perhaps problematic to get warnings out for the afternoon supercell event. So now we see this secondary area of convection fire up across northeast Texas and southwest Arkansas once again. These storms were very much elevated in the wake of that first QLCS. We'll take a look at the surface map here. This is at 8Z.